Welcome to video on regulators. Let us find the definition of a regulator, which is usually found in Google. A person or thing that regulates something is the definition of a regulator. A person or body that supervises a particular industry or business activity is the general definition of a regulator. Let us see what is a voltage regulator. So, definition of a voltage regulator goes: a voltage regulator is an electricity regulation device designed to automatically convert voltage into a specified value. Now we are coming close to what is a voltage regulator is. It's a device which is designed to automatically convert the voltage into a specified value. So let us see one more definition. A voltage regulator is a circuit that is connected between the power source and a load that provides a constant voltage despite variations in the input voltage or output load. Now it is more clarity in the definition of a voltage regulator. It's a circuit that is between the source and the load which provides a constant voltage despite the variations in the input or the output load. Now let us see one more definition. A voltage regulator is designed to automatically maintain a constant voltage level. A voltage regulator may be a simple feed-forward design or may include a negative feedback control loops. Now you're seeing some words like feed-forward design. So it is uh, a circuit having only the forward paths where it will give a desired voltage from the input voltage, and it may give a negative feedback control loop which will control the output voltage constant irrespective of the changes in the load current, and it may use an electromechanical mechanism or it can use electronic component. So this is how the more clarity into the voltage regulator definition goes. Let us see the block diagram of AC to DC converter. So the input is the AC input, and you can see the output is the DC. This is a transformer which is mainly used for reducing the voltage. So it's a step down transformer. There's a bridge rectifier which basically converts an AC signal into a pulsating DC. Now this is not the waveform of a bridge rectifier. This is for a half wave rectifier. For a bridge rectifier, you know that you're going to get this wave will going to repeat during the negative half cycle also. That will be connected to the filter. Now you can see the output of the filter is a ripple voltage. Now you can see here is the regulator. Regulator is one where even if there is a variation in the input voltage, but the output voltage is constant here. So this is what the portion what we are looking at. The output voltage should be constant irrespective of the variations that is happening in this portion. But you can see when the input is varying slowly, the output is also varying here. So this you cannot control. But you can see when the input is changing to a smaller value, but the output voltage is remaining at a constant. So this is what is a regulator, which is used to give a constant voltage irrespective of the variations in the input voltage. Let us see an improved AC to DC converter. So this is a block diagram of the voltage series regulator. Here we have a control element. This is the output voltage. This output voltage will be sampled here, and it is compared with the reference voltage. If the regulated voltage is not equal to the reference voltage, then this will give some control signal to this control element, which will make the output voltage equal to the desired value. So any variations that is happening at the output voltage will be fed back to this control element through this sampling circuit, comparator circuit with a reference voltage, and this will give an appropriate control signal so that this control element will make this output voltage constant. This is how an improved version of A to D converter will look like. Let us see what is this voltage regulation is. two basic categories of voltage regulation. When we say voltage regulation, there are two main things that are involved. One is called as line regulation, the other one is load regulation. The purpose of line regulation is to maintain a nearly constant output voltage when the input voltage varies. So as the name itself indicates, you are regulating the output voltage when there is a change in the line. So line here means the input voltage. The purpose of line regulation is to maintain a nearly constant output voltage when the input voltage varies. So this is what is line regulation means. Similarly, load regulation. The purpose of load regulation is to maintain a nearly constant output voltage when the load varies. So you are trying to maintain the output voltage constant when the load is varied. So that is called as load regulation. You are actually considering two regulations. So in both the cases, we are looking at the output voltage, whether the output voltage remains constant when the input voltage is changing, and in case of load regulation, it is necessary to maintain the output voltage constant when the load varies. The meaning of load varies means, so as we change the load current, the output voltage should remain constant. So this load actually corresponds to the output current. When there is a change in the output current, the output voltage should remain constant. In the line regulation, if there is a change in the input voltage, the output voltage should remain constant. Again, we shall again see what is this line regulation in more detail. Line regulation is the ability to maintain a constant output voltage level on the output channel of a power supply despite the changes in input voltage level. So as we discussed in the previous slide, so you should maintain the output voltage constant in spite the variations in the input level. Again, one more definition. Line regulation is the ability of the power supply to maintain a specified output voltage over changes in the input line voltage. It is expressed as percent of change in the output voltage relative to the change in the input line voltage. So here also it is the same thing. Now we are trying to express in terms of percentage in the output voltage relative to the change in the input line voltage. This is how it looks. See, now this is on the x-axis we have the line voltage, that is the input voltage. On the y-axis we have the output voltage. See, now the ideal characteristics, if the input voltage is increasing, the output voltage is also increasing here. So this is not yet regulated. If the input voltage goes above this, now you can see the input voltage is increasing beyond a certain level. The output voltage is not increasing after this. The output voltage is remaining constant. Meaning, if the input voltage changes after this value to any value greater than that, the output voltage is remaining constant. So this is what is the ideal characteristics. But in case of practical characteristics, so there is a slight variation in the output voltage and the input changes from this value to this value. But you can see that variation of the output voltage is from this level to this level, which is very small. So this is the ideal characteristics. This is a practical characteristics of a line regulation plot. Initially, it is output is varying with the input voltage up to certain value. Afterwards, it remains constant. So if you want to see the line regulation, it is only after this region we have to find out. Let us see what is load regulation. Load regulation is the capacity to maintain a constant voltage, level on the output channel of a power supply despite the changes in supply load. So that is, if you are trying to draw more and more current also, the output voltage should remain constant. So let me make some one modification there. Instead of saying voltage or the current, let me say only the voltage. Now I have removed that. Now load regulation is the capability to maintain a constant voltage level on the output channel of a power supply despite changes in the supply's load. So when you say supply's load, it is the change in the resistance that is connected to the supply output. So supply means the power supply what we are talking about. This is how a load regulation plot looks like. So you can see now. So on the x-axis we have the resistance R, which will also represent the load of a circuit, and V0 is the output voltage. Under ideal characteristics, when the resistance is very small here, so when the resistance is very small, so actually this is when we say resistance is small means the current is more. So let us assume the resistance is more here. The resistance is more, the current is least. So this, let us change this to IL instead of resistance. Let me change. And this is fine now. In case of load regulation plot, when the load current IL is 0, the output voltage is some constant value. Under ideal characteristics, even if the load current increases from 0 to a larger value, the ideal characteristics shows that the voltage should not change. But in case of the practical characteristics, as the load current increases, naturally the output voltage starts reducing. So this is a typical load regulation characteristics of a regulator. Ideally, it should remain constant even if the load changes from 0 ampere to a larger current. But practically, the output voltage decreases as the load current increases. These are the different voltage regulators available. The easiest or the simplest form of voltage regulator is a Zener diode. It can be in the form of, it can be of the rating 6 volts, 12 volts, or any other required voltage we can get it. And other regulators are 78XX, which is a positive regulator. So this XX is the actual voltage. So we can have 7805, 7812. So this 7805 will actually give a plus 5 volts constant DC voltage, and 7812 will give plus 12 volts. Similarly, this 79XX is a negative voltage regulator, which will give a constant minus 5 volt and minus 12 volts. And this LM317 and LM138 are adjustable voltage regulators. In the previous two, that is 78XX and 79XX, are the fixed voltages. If you want to get any voltage other than 5, 12, something like 3.3, 2.4, so all those things are not possible in this 78 series. On 79 series, we have to go for this adjustable voltage regulators to get the required value of constant voltage. And this LT30325 is a dual voltage regulator where we'll get both positive and negative voltage simultaneously using the same regulator, that is LT stands for the linear technology 3032. So we'll be doing this simulation using this LT3032 for both positive and negative voltage in the next video. So this is what the data sheet of a 7805 looks like. As you can see now, the output voltage will vary from, this is 7805 stands for 5 volt regulator. The typical voltages will be 5, the minimum will be 4.8, the maximum will be 5.2. This is true only if the input voltage is between 7 to 20 volt. If the input voltage is between 7 to 20, the output voltage varies from minimum of 4.8 to maximum of 5.2. It's almost pretty much constant, provided I0 is between 5 milliampere to 1 ampere. And you can see similarly the load regulation. If the current I0 varies from 5 milliampere to 1.5 ampere, you can see this is the amount of change in current. You can see the change in the output voltage is hardly 15 millivolt is the typical change. You can have a maximum of 10 millivolt change in the output voltage. Usually this voltage should be as small as possible, so which is pretty good in case of 7805. It is only 15 millivolt change if the current changes from 5 milliampere to 1.5 amperes. So this is how we can see the data sheet of various regulators and try to identify their line regulation and load regulation. This has got a pretty good load regulation, and of course the line regulation also fine, because even if the input voltage is 20, output is 5. From 7 to 20 it will be always at 5 volt.